A light can be defined by three fundamental properties: its color, or so-called its wavelength, its polarization, or where the electric field is oriented with respect to the propagation direction, and the propagation direction of light. Hi, my name is Yichen Shen. I'm a third-year graduate student in Professor Selectivity's lab. People have been trying to control light by making devices that can select light based on each of these three fundamental properties. So materials that can select light based on their polarizations are also called polarizers. Stained glass is a traditional wavelength selective filter in that sense, and it has existed for over 1,000 years. So light selections based on their wavelength and polarizations has been there for quite a while. However, it is, as to the best of our knowledge, it is the first time that we demonstrate a light selecting device based on their propagation direction in the whole visible spectrum. The key idea we used in our device was angle, so-called Brewster angle. So when the light was shining on the interface of two different materials, there is a magic angle called Brewster angle. When the light was coming in exactly at that Brewster angle, there will be no reflection of the light on the interface. So what we made is we use only two different materials that has two refractive index, and we use these two materials to make a device that consists of around 100 layers. So in that case, we made 100 interfaces. When the light was propagating at the Brewster angle, it will have no reflection at each of these 100 interfaces. But when the light was propagating in other angles, there will be more or less some reflection at each interface. And then when it passed through 100 interfaces, all those reflections will add up, which makes the light propagating in other angles to be completely reflected. It might be hard for you to think of a device such that when the light coming from all the directions shining on the device, only one propagation direction's light can go through the device, while light propagated in other directions will be reflected. For example, we can use a light angular selective device in optical detectors, such as telescope. So when you use a telescope to look at the small dim stars, for many times you might feel that all those bright stars surrounding the dim stars are very distractive. Selecting of light based on their wavelength and polarizations has enabled many applications, and right now there are billions of dollars industry based on these two devices. Since light selecting based on their propagation are also very fundamental, that we believe it can have a potential to enable as many applications and create much more scientific innovations in the future.